All right, I'd like to welcome everyone back to the Ray Tracing in One Weekend project. This is part two. In part one, we made it through about the first 6 parts of the project. Today, we're going to try to finish the project, or at least in this part. It's a new day for me. I took the rest of the day off yesterday. The thing I thought we would start with before we get into it is I wanted to say a little bit more about one piece of code that was written yesterday, and it was the implementation of hittable lists. I think by far this was probably the most complicated piece of code written in the first part. And it definitely involves the most sort of Rust concepts. So I have the code up on the screen, and you're seeing a lot of things in here: box and lifetimes and dyn and impl, and all these things. And you know, if you're new to Rust, you might look at that and just say, "Oh, my head is just completely exploded." I think the thing to understand with this code is that I think there are actually kind of 3 different concerns in play. One concern is just the nature of the problem. Okay, and the problem in this case is ray tracing. Okay, so we're going to ray trace some scene. Part of the problem with ray tracing is that there are going to be different objects in the world. There might be spheres, there might be cubes, there could be trees. I mean, who knows what the world is going to be? There's going to be some scene that is being rendered, and the objects in that scene are fairly open-ended. Like as this code were to grow, you could have a kind of an open-ended set of objects. And to code something like that, normally, like if you were in Python or C++ or something like that, you would probably do object-oriented programming. You'd make a base class or an abstract class. You would have objects inherit from that, and so forth. Rust does not really have that. But it does have this trait system, and one of the things that we defined was a hittable trait. Basically, you have this trait down here. It's some object that can be hit. And then what we're doing is we're sort of classifying objects by that. So in part of this code, what I am doing is I am building a list of hittable objects. Okay, so I have that. The other problem-specific thing in this is the nature of, I would say, composition. The purpose of this hittable list is basically to act as a container of some kind, right? So you have a container of objects. So you have all these objects in there. All of those are hittable. And then, you know, this is the list object here. I'm actually thinking hard about just the relationship of this list to the hittable objects, specifically the relationship of ownership. Does the outer list own the objects inside? I think it should. I think it does. I think it makes sense for the outer thing to own the internal things. Okay, so this is kind of the nature of composition, and this code has been written with that in mind. I mean, it's a little bit subtle, but ownership is actually a really important thing in Rust. I mean, basically, at any point in the code, you need to be able to point to an object and identify who the owner of that object is. Okay, so one of the ways that this has been structured is that this add method that takes in an object here, that is basically owned. Okay, just the way that is structured there, it's like you're basically giving me an object, and I'm going to take ownership of it. Okay, so I'm taking ownership there. This act of putting it into the box, and I'll say more about that in a second, but this is also an ownership relationship. Okay, so this is essentially establishing that I own this thing, this list of objects. Everything about this is structured around ownership. And it's like, you're giving me an object, I'm taking ownership of it. Yes, I'm putting it in a vector, but I am taking ownership, I'm taking responsibility for the object. Part of what that means in terms of Rust is that if this hittable list goes away, all of the objects inside go away too. It's like, okay, you have like this outer container. Okay, so part of what you're seeing here is me thinking about the problem and I'm thinking about ownership. This is a little bit different than the project write-up, by the way. I mean, if you go look at the hittable list implementation that is here, this C++ code is also thinking about ownership, but it is using a shared pointer for this. Let me kind of point it out. Shared pointer, hittable object. That's also about ownership, but the key word there is shared. Shared means that the object could potentially be owned by everybody, okay? Or it's like shared by many different things, okay? It's like it's reference counting, okay, in C++. This Rust code is not reference counting. There's basically a single owner, and it's the hittable list. That's the owner. There is no other owner, okay? So it's a very subtle, subtle difference between the two. Okay, so that's one concern. The second concern with this code is that I am dealing with some Rust internal details. Okay, so Rust at its core is about, it's a systems programming language. It is often fixated on kind of low-level details that you might not think about if you're coming from Python or Java or something like that. One of the details that this code needs to deal with is memory layout. So, I mentioned it in the first part, but when you have a vector, there is basically, you're creating like an array of items. Okay, so you have this array that is being created. And all of the items in there have to have some space allocated to it. Okay, so you have some item in there, and that has to be known. So there has to be some kind of fixed size that is being established there. The problem is, I don't know what that fixed size is if I'm putting arbitrary objects in here. Like this dyn hittable thing, this is basically any object. I don't know how big that is. I mean, it could be anything. It could be sphere or box or hittable list. It could be recursive. So the purpose of the box is basically a Rust implementation detail to fix that. This is a box is essentially like an owned pointer. Okay, so what's going to happen with that is instead of an item being put in the vector, okay, forget about the item, you're going to have a memory address put in the vector, and then that's going to point at the item. Okay, so it's a little bit of indirection. I look at that, and frankly, it's like, okay, that's a weird fiddly detail, but it's kind of necessary. It's like Rust, wants me to think about how I'm allocating memory, and I'm being forced to confront that here. So that's another thing that's entering the picture. And then another Rust detail is the use of the lifetime specifier up here. This is probably the most, maybe the most intimidating part of this code. If you're new to Rust, is what is that? What is that about? So what is going on there? I made a comment about it last time where I said, object has no components with shorter lifetime. It's like, what the hell does that mean? Okay, so I wanted to say a little bit more about what that means. Maybe in sort of words, what the lifetime specifier is doing there is it's saying anything that is put into the list lives as long as the list does. Now, at first glance, it's going to seem really weird. Like you look at that and say, well, of course it's going to live as long as the list does, because it owns it. Like, why wouldn't it live as long? Like, I'm giving ownership to the thing. So why do I need a lifetime specifier on there? So let me do an example where this comes into play. Okay, so where this lifetime comes into play is in the implementation of the other object. Okay, so let's say we went to the sphere, like the sphere structure here. Okay, so this is sphere. It has a center and a radius on it. Let's say for reasons unknown, I don't know why I'm doing this, I wanted to give the sphere a name. And I wanted it to be like a string of some kind. Okay, name of sphere. Again, I don't know why I'm doing this, but let's just hypothetically say that okay, there's going to be a name of a string on there. That is not going to compile. I mean, we can build it, but I can tell you right now, it's not going to compile. Well, first of all, it's not going to compile because I don't have a name in here. So let me give it a name. Okay, so let's do that. It's still not going to compile elsewhere because okay, now I need to give it the argument for the sphere new. So let's go to let's fix that. Everywhere I created a new sphere, I now need to give it a name. Okay. I don't know, let's call this one ball. And let's call this one ground or something like that. Okay, so we're adding spheres to the world, so I'm fixing that. It's not going to compile because you're going to get this message about a lifetime parameter. And actually, okay, so Rust will highlight this thing and it'll say, okay, you're missing this named lifetime parameter. And then it suggests that what you need to add here is you need to add the lifetime and stir. Okay, and like already your people are you're running for the hills. You're saying, oh God, I don't want to do that. Okay, so I have to put like this on there, and then it wants that, and right away. Okay, so like what is happening here? What is happening is you are basically specifying a relationship in the code. Like so, this A, that's not a piece of data. Okay, it's not like an integer or anything like that. What you are doing is essentially establishing a relationship between sphere and that piece of data. Okay, the stir. Okay, okay. First of all, the fact that has an ampersand on it means that this is some borrowed piece of data. I do not own the data, and the purpose of the lifetime is essentially to say that the sphere and that piece of data are related, and specifically what it means is that name has to exist at least as long as sphere exists. Okay, so there's some notion of kind of, I don't know, maybe like a temporal notion here that name exists in the program somewhere, and that name needs to stick around at least as long as the sphere sticks around. Okay, so the purpose of the lifetime is that. Okay, and so what we're going to have to do is put lifetime on there. We're also going to have to patch up some other code to put lifetimes on here, by the way. That's maybe a little bit annoying and syntactically kind of complicated, but I'm going to have to put that on there. Let's see if it, okay. No, okay, I need to put it one more place. Okay, so I put the lifetime on there. It's essentially just saying, okay, whatever that name is, it has to live as long as the sphere lives. Okay, I realize that this is, looks kind of intimidating there. Now, here's the thing that's going on with the previous code. It turns out that this lifetime here is actually what the other lifetime is about. This hittable list, it's actually, this is related to that. Okay, so when I say something here like this implementation of hittable plus the quote A, I'm basically saying, okay, you're gonna give me some kind of hittable object plus some kind of lifetime for that object, and then Rust is sort of asking, basically saying that whatever the lifetime of that hittable object is, it's related to the lifetime of hittable live. Like, has to live at least as long. Now, let me give a counter example of where this can break. Okay, you're looking at this probably, you're just saying, oh, what the hell is going on? Okay, so here's where something like that might fall down. So let me go to the main program here. What I'm going to do here is I'm going to make a name as just like a string or something. Okay, let's say I said name from ball. Okay, so this is a string object. One of the things that I could do here, at least I hope I can do, is I should be able to just pass in like at name into sphere. Okay, so what I'm doing is like indirectly creating the string, you know, like this, and then I'm passing it in. That should hopefully compile. Okay, it compiled just fine. Let me run it to just as a sanity check to make sure I'm not, you know, deceiving myself. Okay, still runs, still produces the same image before. So what I've got is this string object. What is happening with the lifetime is that Rust is basically making sure that this string up here lives at least as long as this world exists, right? I'm creating this world and I'm putting two spheres in there. In order for that to be correct, that name that got created needs to stick around. Here's an example of where it might not stick around. I'm going to kind of force this a little bit. What I'm going to do here is I'm going to make like a little inner scope of some kind. Okay, so I'm going to put like a little inner block of code in here. What's going to happen with this is that this string name will basically exist to that point, and then it will be destroyed. Okay, so it will be destroyed. What I'm hoping that will happen here is that when I build this, Rust will look at that and say, no way. Like whatever you're doing there is a violation of the whole like lifetime rules. In fact, okay, so it comes back and you're getting like a whole error message from the borrow checker, and it basically says name does not live long enough. That's awesome, actually. I mean, that is totally maybe one of the points of Rust. I mean, basically Rust has looked at this code and says, you know, okay, you have this object that you've created, this sphere, that is borrowing some piece of data from here. Yes, you're putting it into this world object and so forth, but I have detected that this component is going away, and you can't do that. Okay, so the purpose of the lifetime in this hittable list, even though it looked kind of cryptic at the time, is basically putting some assurance about the properties of objects that you're putting in the list. Yes, you own the objects, but those objects have to live long enough. Like they can't have like any kind of internal component or something that might go away. Okay, so that is another detail that is happening here. I personally, I think it's a very difficult detail, frankly, to wrap one's brain around, but that's what's happening. The final thing that I wanted to mention, which is also a little bit subtle, maybe hard to appreciate, but I wanted to talk about why am I using Dyn in one place and Impl in the other place? Dyn basically means that the object dynamically implements hittable. It's like you give me some object, I don't know what it is, at runtime it has hittable. Impl sort of seems to have the same behavior. It's like, okay, give me an object that's hittable and so forth. And so why am I using like the two things here? Couldn't I just go here? Why couldn't I just say Dyn there? Like why couldn't I say Dyn on that? So let me change that. Actually, let me fix the main to not do the. Let me make sure that works again. Okay, so let me change the code to do Dyn here. If I try to build that, it actually complains about the box thing again, it's essentially complaining that it's it's the wrong type, and okay, so it's Dyn hittable, found spheres. It's really unhappy with the type on that. And then it suggests, it has a time. So it absolutely hates that. One of the things that you might try to do is maybe put like the box around that. I mean, you could the kind of restructure it like this. What I'm trying to do here is line up the types. Okay, so I have this type here, and I have the type here, and I'm trying to basically make, okay, I'm looking at that saying, yeah, okay, those are the same. Let's go with that. Let's try that. Okay, so now what it's happening is it's still not compiling, but it's complaining about my use of the world add function. You can see that down here. World add box new. So what it wants me to do is it wants me to put the box new all the way out here in main. Okay, so I'm in the main function. Wants to do that. Now it's complaining about like some, okay, yeah, I don't even know what it's complaining. Now it's complaining about the name not living long enough. Okay. I don't even know what's going on. I'm like digging like a huge hole for myself. Let's just get rid of the name and do that. See what happens here. The things in quote literals like that live for the whole program. Okay, so the thing compiles, but I am super grumpy at this point. I hate this, actually. One of the things that I hate about it is that the presence of the box there feels like a leaky implementation detail. Why would I care about that? I mean, like the whole presence of the box in hittable list is some kind of internal implementation detail related to data representation. I don't want that being part of the interface. Like I don't want outside users knowing that there's a box in there. Like I tend to think of objects as being this kind of opaque thing, right? Where you have an object and it's like, okay, inside there's some box thing going on because Rust wants that. I don't want that on the outside. Like I don't want the user out here interacting with this thing to be worried about the box thing in there. Okay, so part of the reason why I was using impl is that just the way that Rust handles that is a little bit different internally. What is happening with that is that Rust actually makes sort of a specialized function for just this kind of object, and like it doesn't have the same problems that the dyne does, and honestly, it lets me hide internal detail. Like I don't have to, like I can go here, and I can just say, okay, forget about the box thing. Okay, yes, there's a box, but it's inside, and I don't care about that. Okay, so that may not be a complete explanation of that, but that's maybe the third concern with this hittable list. I mean, I think you could probably teach a whole course off the hittable list, just all the different aspects of this, about understanding the nature of the problem, understanding the concerns of Rust related to things like memory layout and lifetimes of things, and then also just maybe understanding the concerns of encapsulation, like leaking details. I want this object to be something nice to use on the outside, and I don't want internal details leaking out. So that's a long discussion, but filling in some details from last time. So having said that, we're going to move on into some later parts of the project here. Basically, the next few parts of the project are a lot of refactoring in the code. We're essentially going to create a camera structure, and we're going to introduce some camera features such as anti-aliasing, some random numbers, and things like that. So in the next few parts, I wouldn't say that there's much in the way of maybe new Rust concepts. So what I'm going to do without kind of further ado here is actually just kind of start coding what they describe. The first thing that's going to happen is part of this main program, like all of this stuff here with the camera code, is basically going to get moved into its own struct. So let's go ahead and let's go ahead and start with that. So I'm just gonna kind of follow the skeleton of the C++ code that they have here. So we're gonna make a new file, camera. Okay, it doesn't look like they give me any fields yet, but here's this implementation of hittable going on again. Okay, so we're gonna do that. We also have a function initialize, which I will have to talk more about in a bit. And then they also have a function ray color. Hittable world. Okay, this is sort of interesting. What's going on there? Okay, so let's we'll stick with that for now. Very first thing we're going to do is add it to the project, and simply make sure that it compiles. Okay, so that looks good. Okay, it looks like they're moving some code from main into there, so I'm going to do a little cut and paste. And some slight differences because we're using the option type for the hit record. I have to deal with that. Again, let's see if it compiles. Okay, it wants some interval stuff. It also wants dot product, apparently. Okay, so we're good with that. And then it looks like, okay, so we're introducing some, well, okay, so now we're introducing a whole bunch of variables and things into the code. So this looks like it's going to keep me busy for a little while here. Now this is kind of interesting, by the way. In the C++ code, they've got a default value set up of 1.0. Rust does not have that, by the way, or at least I can't do it like that. We'll talk about how to fix that in a second. Okay, so we've got some public things, and then it looks like we've got a whole slew of private variables down here. Bunch of private variables. Looks like I'm bringing in more data types. I'm gonna have to address that dot product thing. I'm not sure I like that, but we'll get to that a little bit later. Okay, so we've got some private variables. Now, here's one of the things that's kind of, I don't know, sort of screwy about this camera class. You know, okay, so one of the things that he's done is they've defined this method initialize that essentially goes through and sets all these private attributes. I'm going to follow the same pattern. I do look at it and I find it a little weird. Okay, maybe from like just a programming point of view to do that, but I'm gonna have a mutable self like that. Okay, mutable self. I'm gonna set up all those parameters the same way. We were kind of already doing that, I believe, in the main function actually. So what I'm gonna do is I'm gonna kind of cut and paste some code here. I'm gonna have to modify it extensively, but this is basically the initialization code from before. I'm gonna take the world out of here. Okay, yeah, we're gonna have to patch this up a little bit. Okay, so what we're doing now is modifying attributes of the object. I don't know what's the center? Okay, so 0.3 new 0.0. I don't know where that was defined before, but okay, so we've got that. Is focal length a parameter? So, some of these are actually just variables, and so, okay, center. Okay, so that's as before. That's before. I'm just looking at what needs to be set here. It's an ungodly mess of C++ where you're not sure what's a variable, what's an attribute. Okay, so you've got, let's get rid of that viewport width, and then I think those are okay, and then these are going to be okay. So those are going to be attributes. Fortunately, if I do screw this up, the Rust compiler will definitely yell at me about this. Okay, so okay, they changed the name of a variable. Okay, self.center, focal length, viewport U. Okay. I think these are attributes. Okay, so I got that. Let me talk about well, actually, okay. So let's stick with that. Initialize. Got that. Okay. Well, let's see if that compiles at least. That will tell me if I've got like things screwed up here a little bit. Okay, image height. Yeah, okay, I'm missing a self on that. And another self over here. This camera class is going to be a real mess later on, by the way, but for reasons that will become clear. It's just there's a lot of sort of just pieces of this thing. Or it has a very complicated kind of initialization. And there's going to be more fields added to it as we go. So unfortunately, you haven't seen the end of it yet. Okay, let's just keep working on it. Okay, so at least that's compiling now. Okay, there's still some things that are a little bit unresolved. The default value of the aspect ratio and image width, I'm gonna have to deal with that. Some other things here. Okay, so what's gonna happen here? Okay, so what we're gonna do in the main program, it looks like, is all of the camera code is going to go away. Okay, so all this stuff with the image parameter is going to go. It looks like the ray color is going to go away, so that is going to get moved. And then we're going to have the world will stick around. I might take the name out of there at some point, but let's go ahead and leave it for now. We can treat the name as like a documentation or something. Okay, so we're going to create that, and then we're going to create kind of a camera. Oh, actually, this is a little bit of a problem. Okay, I'll put a question mark on that. Let's say we're going to do new on that. Okay, let's say we're going to do new, and then what we're going to do is set up some parameters. Okay, so aspect ratio equal. Image width equals 400, and then do render at world. Okay, so I'm gonna do that. That is what they're kind of teaching here. I guess the question is, did I actually do the render thing? Oh, actually, I didn't fill in the render function yet. So let's go ahead and do that. The rendering is this stuff here, where we make the actual picture. Okay, so this is going to be the same. Pretty much the same code as before. There's a few things that are a little bit annoying about this. The image width and the image height are now attributes. Unfortunately, I can't do that. Rust doesn't like that, so but I can fix that. I can pull them out over here. So I'm going to fix that. These are going to become self. A whole bunch of like self parameters here. No, I don't need a self there. I think this got renamed to center, so that's gonna do that. Okay, so that looks like the render. The only other thing that's a little weird in the render is that he calls initialize on that. And it turns out that's not gonna work unless I observe the mutability on that. So I'm gonna have to make that mutable. I don't know. Does that look okay? Well, okay. Let's do that. Okay. So essentially, like all this prior code. Right for now, I'm going to comment it out. Okay. So just because I don't want to delete it right away. Basically, what's happening is just kind of a big refactoring of this code. So you're going to create the world separately, and then you're going to create the camera code separately, and then at the end you're going to render the world in the camera. It occurs to me that there may be one other thing I messed up here. I think you have to, like, ray color is a method on myself, so I'm going to have to say self dot ray color. And there's probably a whole bunch of missing, I don't know, are there a bunch of missing things on this? Yeah, maybe I'll probably need to use camera here. Okay. Rust will complain loudly if I mess this up. So, the camera new, and also I need to pass in. it's basically saying I don't need to do the at world thing here. Oh, because it's already an at. Okay. Okay, so we can fix that. Let's talk about the new for a second. Okay, so one of the things that it's complaining about is the camera new, and I mentioned earlier that we have this problem with there's like some default values that get set up. So let's focus on the new here. So I don't know whether they really define like a new method on this camera object. So let's say you wanted to have a new where you just didn't provide any options at all like that. Okay, so you could just have a new with no arguments. One of the things that's going to happen here is that you are essentially going to have to specify values for every single variable. I can definitely put my defaults here. I can say aspect ratio, 1.0. I can say image width, 100. And then I could keep going on this. I mean, image height, 0 or something like. Okay. So Rust is not going to allow me to not specify the values here. So, I mean, one thing that I'm going to have to do is basically provide like default values for those. A little bit annoying to do that. Maybe I'll just do it for now because it's like easy to do. But there is another way to do this that we'll get to. But Rust is not going to allow those to be uninitialized. Okay, so with new, I'm going to have to essentially set up values for all of these private variables. But let's just start with that, and then we'll try to fix it later. Right now, I'm just trying to get it to compile. Okay, what is it complaining about now? Oh, unused import could not compile. Oh, right color. Okay. There's a function right color from color that I did not import here. Okay, so let's put that on there. Okay, so it compiles. If I have done this right, we should be able to run it, and hopefully we'll get the same image as before. Keep my fingers crossed anyway. Okay, good. Okay, so a lot of refactoring on the code. Some things that are a little annoying is all this private variable initialization. Another thing is that I think honestly is a little wonky is just the whole initialization of this camera. This feels sort of weird to me. I'm not gonna sugarcoat that. It feels a little strange, and but I'm gonna leave it for the time being, and we'll address it later on. A lot of this code in main can go away. Okay, so we're getting rid of that. There's probably a lot of unused imports that we can get rid of here, or at least like we don't need to use like the ray thing anymore. I don't really see the. I don't know. Do I see hittable in here? Yeah, I don't know. There's a lot of kind of like pieces of that I can probably kind of simplify, because a lot of that got moved inside of the the camera thing. So okay, so I think that's section 7 now. Okay, so we got section 7. What we're gonna do in the next part is we're going to make a few little enhancements to the camera. One of the things that we're going to do is anti-aliasing, and without getting into too much detail on that, it's just going to make the image a little bit more, fuzzy. So it's not so jagged on the edge here. So to do this, it's mostly just introducing some new features to the camera class. So let's kind of work through that. Okay, one of the things that it wants me to do is write some random number utilities. Okay, he's creating a file rtweekend.a. It's probably because Peter has too much pride to name a module util. I'm going to name it util. Okay, so I'm going to have util here. Just utility functions, of course. I'm going to put the random number stuff in there. So it looks like he wants like two functions. What does he want here? He wants like some public function like random double. I'm going to call it random F64, just because F64 is the name for that. And then it looks like there's another function. Oh, this is kind of interesting. Rust does not have operator or function overloading. Like you can't have the same function with the same name. At least not like C++ like that. So if I'm gonna do that, I have to give it a different name. Okay, so I can fill in code there. One bit of bad news is that Rust does not have random numbers built into the standard library, at least not that I'm aware of anyway. So I'm going to install a crate for this, and I'm gonna rely on something called FastRan because it's fairly simple. So there's a external library, I think, that will let me do this. I mean, I'm pretty sure that's what happens here. To 1.0, but this is something that I'm going to have to add to my project. So in order to do this, I'm going to do cargo add, I think, FastRan. Okay, so I'm taking on a dependency on my project right now. And so it's going to install that. I'm going to add this util thing to my program. Let's actually make sure that it compiles after doing this. Okay, just got the extra semicolon stuck on there by accident. Okay, so it looks like that's compiling okay. Again, that was me taking on a dependency to do the FastRan. Maybe I'll make a note. I added that using cargo add FastRan. Okay, so that's what I did there. I think Rust already has like degree to radians built into it somewhere, so I'm not gonna code that. Let's see what else we've got going on here. Okay, we're adding a method to the interval object or interval struct. Some kind of clamping thing. Okay, just clamping it to a range here. Okay, so we're going to add that. Oh, got a typo in my code. Okay. And self. Oh, and I need to. Yeah, okay. Gotta love C++ about the self there. Okay. Looks like there's a little clamping in the right color. Okay, that's okay. Why not? Okay, fine with that. So what is he doing in the right color here? It looks like he is. Okay, looks like he's making an interval here, a static const interval. Actually, we might be able to do that. Let's actually let's try that. This is kind of making like a private, I don't know, like a private global variable or something like that. So let's put it up there, and then let's, okay, what is he doing here? He's gonna do, okay. Wow, okay. He's doing like some kind of clamping thing. Oh, what is he calling that? Oh, intensity. Okay, so that looks like that. Okay, let's make sure that that actually builds. Constant. Let's see. Cannot call non-const associated interval new. Calls and constants. I might be able to fix the. Can I just say that that's const on that? It might be. I have to confess I haven't done a whole lot with const functions in Rust. Okay, it looks like if I declare that as a const. Okay, looks okay. Let's just run it. Make sure that we're still getting like image as before. If that clamp thing is messed. Okay, we're still getting the image as before. Okay, so a little bit of refactoring on that, and then looks like, okay, we're introducing some new features into the camera object. Okay, so it looks like we're going to introduce a new public variable. Go ahead and give that a default value. And then looks like we are modifying the render function in some way here. So let's see what is going on with this. Pixel color is going to be, okay, it looks like we're creating like a new color. And then we're going to do some kind of for loop. Do some get ray. Okay, this get ray looks like something that's going to have to be coded in a second. So we're getting an array. And then we're going to do a plus equal on array color. The world. Okay, that's kind of an interesting little formulation of code there. In order for that to work, pixel color is going to have to be mutable. Okay, so looks like what we're doing, okay, we're taking a bunch of colors and we're basically gonna get a bunch of sample, like a bunch of colors kind of added together in some way. Let me comment out this stuff. Okay, that's what it was before. And then we're gonna write the color. Oh, and then there's a new calculation here. Pixel sample scale times pixel color. It looks like that is a new private variable that got added. Okay, so this is, yeah, the camera class is yeah, you're already getting like a sample of what is going to happen with that. Oh, that's going to be 0, 0. Okay, so we're adding a new private variable in there, and then it looks like there's some there's some kind of initialization of that. 1.0 divided by self samples per pixel. It's going to be a miracle if this works afterwards. Okay, so okay, and then we're introducing a new function or new method, get ray. We're giving it an I and a J, so those are like the pixel, I guess the pixel nut values there, and then we're returning a ray back. Wow, okay, a lot of pieces of this. Okay, so there's also a sample square method down there. A lot of pieces of this. Minus 64 plus offset. I have a feeling that that we're going to have to implement some new features of color and or possibly vector here. So we'll find out in a second. So okay, so returning that, and then it looks like we have this like sample square thing. It's a little weird to be putting this in this class, but or this struct, but I guess I'll keep it there for now. So we're going to have vec3 of some random F64, 1.5. Wow, okay, so a lot of pieces of that. I know that I'm going to need that random 64 thing. Okay, so let's include that. Okay, then we need to add, in our main, we need to set up samples per pixel somewhere. Okay, we're in there. This is definitely not going to compile, but let's see what happens and fix what we need to fix what we need. Okay, so a couple of things that are Okay, so we're gonna like kind of like type error things. It looks like we've got some, okay, just some basic typographical. Well, actually, that's not as bad as I thought. Okay. The first thing is just a type error in initialization. Rust again, really picky about mathematical calculations. Okay, so I'm gonna have to fix that, and then it looks like maybe just just a missing cell on that. I don't know. Let's see what happens. Okay, add a sign. Okay, this is maybe the part that I was thinking about here. It turns out that the plus equal operator, that is one of these traits that needs to be implemented. It's complaining that I don't have that for color. So let's go back to color here. What it wants me to do is implement, basically add a sign for color. Just kind of riffing on earlier things. If you don't know what to do there, you can just say that you're implementing it and then watch what happens in the compiler, and it will tell you what it wants. It'll say, oh, you need to include add a sign there. Okay, so it will kind of fill in some detail. So I need add a sign up here. And then if you kind of keep working with the compiler, it will even tell you like what method it wants. Okay, so it tells me that I want like I need to have some function in here called add a sign. It needs to be a mutable self. And then, I don't know, looks like it maybe wants color on that. And then it's mutable, so what we're gonna do is basically just modify ourselves, I guess. Okay, so let's try that and see. Okay, so we're back in business, and let's run it, and let's see if we still get an image. It might be a little bit hard to tell whether it's actually anti-aliased or not, depending on what it looks like, but okay, well, maybe if I zoom in on it, we could see that. I don't know whether let me see if I can do that really easily here with the, I might have to pull up like a different tool to do that. Just gonna redirect it to an image here. And then I'm gonna pull the image up in just preview on the Mac and just kind of zoom in on it. Let's see. Okay. Yeah. Okay. That looks okay. Okay. That's good. So that concludes section 8 on the camera and anti-aliasing. I'm gonna pause the recording for a second to take a short break. When we come back, what we're gonna do is introduce some materials into the picture. What we're going to do is we'll end up making like metals and kind of diffuse materials and glass and other things like that. But I'm going to pause the recording for a second. We'll take a short break. Okay, we're going to continue with the project in this section 9. Essentially what we're going to start doing here is introducing the idea of having materials. And I'm not going to get too much into the math, but the gist of it is, you're going to have rays injected into the scene. They're going to hit something, and we're going to start thinking about what did they hit? What happens with the ray? Does the light ray reflect off? Does it get absorbed? Does it go off in a different direction, and so forth? So section 9 is dealing with that. Most of this is going to be some enhancements of code that we've already got, so we'll start going through that. It looks like one of the enhancements is introducing the ability to have random vectors. Okay, so let's go to the vector class. We're just going to kind of go through the code and make some of these changes that are required here. So it looks looks like we're going to have a ability to make a random vector of some kind. The use of static there, it tells me that this is more of a construction function. So it's going to be sort of like 0 and new and so forth up here. So what we're going to do with this is new. Okay, so we're going to code that. Need to pull that in, and then the other thing it looks like is there's a function for doing kind of a vector with a random set of ranges. As noted, Rust does not have overloaded functions, so I'm going to have to give it a different name. I already forgot what I called that in util. F64, right? Yeah, let's just copy that. Okay, so a couple of functions there. Looks like we're also adding a random unit vector function. Is this what is that? Is that a function or is that a? Huh. Okay. Well, let's put it here. It's kind of a let's put it. Okay, that looks like it's a method on the thing. Okay, so that's going to be. Let's put it down here. Oh, that's kind of interesting. He's enters an infinite loop here. Okay, so that's kind of interesting. Okay, so all right, so we're gonna let PV equal. So it looks, okay. There's probably some description of like why he's going in a loop like that. Okay, it's some kind of approximation technique. Okay, so we're gonna loop and do like that. While true, just do loop for that. Okay, I need a return type on this thing. So let's do that. Then he's okay. There's a slight enhancement that he is doing there. I think we can pretty much copy that. Okay, so just some enhancements on the okay, and let's make sure all that compiles first. No, it does not compile. Cannot find random 64. Yeah, okay. Create util. I have it spelled wrong? What is that complaining about? Oh, okay, no, okay. Just my eyes are okay. F64. That's what I was complaining about. Okay, so that at least compiles. Let's see. It looks like we're introducing more more helper functions in Vec3. Okay, so there's this random on unit hemisphere. Is that okay? I think that needs to be a self on that. Back 3 random. Actually, maybe. Does that need to be? Maybe no. Maybe that does not. Okay. No. Okay. No. Take that back. That does not look like a method on the. Method on this, and I'm not even sure that this is a method on a random unit vector. Yeah, maybe not. Okay, well, let's kind of just roll with it here. Okay, normal is going to be vec3. Okay, so all right, so let's code. Let's make sure that we're still compiling there. Okay, and then it looks like. Okay, what are we doing here? Okay, so we're going back to the camera class. There's the ray color. So it looks like what's happening here is that if the thing hits. What we're going to do is make like a direction. We pass in the normal vector there. Okay, we do that, and then we're going to looks like we're recursively calling ourselves. Okay, interesting. So it looks like, okay, so we're going to basically scatter until we don't hit anything anymore. Let's see if that, I'm not sure if that's going to build, but, okay, yeah, okay. So this is creating a new ray here, and I just need to make it line up with the argument, need to make it line up with the type there. Okay, so that runs. Let's see what happens with that. Now you're seeing why the little progress indicator is nice to have. It takes a lot longer to run once you put in the anti-aliasing on. Okay, looks pretty similar to me. I don't know. I can't say it's totally correct, but I'm gonna eyeball it and say that it's correct. looks like here they're introducing more features into the camera, like a max depth parameter of some kind. Okay, they're going to set that to 10. Okay, so go to max depth. Oh, okay. They're going to use this as a limit on the recursion. Okay, so I get what's going on here. So what's going on is they're introducing a depth argument onto the ray color thing. So it'll probably start off with like max depth on that, and then we will decrement it. Putting the check here about the exceeding the ray bounce limit, and then when I recursively call this thing, we will decrement the depth. And then they have a main there setting the max depth to 50 or something like that. Okay, let's see if that builds. They say that you should basically get the same results. I'm not expecting it to look too much different. Okay, I'll trust that I'm doing the right thing there. It looks like we've got another little tiny enhancement, one line change to the code in the camera here. What's going on here? That's in the ray hit. World hit inner. Oh, okay, they're pushing it just slightly away from 0, it looks like. Got the 0.001 here, changing that there. It's actually kind of nice to be making just some minor code changes that I can understand, as opposed to some of the crazy lifetime stuff. Okay, it's looking about the same. Okay, now it looks like we're going to introduce some more math here. A true Lambertian reflection, huh? Okay. Okay, so it looks like okay. This is a one-line change. That's kind of nice. Maybe that random hemisphere thing was just a temporary. It looks like that's going away. So is this okay? So this is going to be rec normal plus vec3 random unit vector. Is that it? Is that what's going on with that? I don't know. Let's try it. Okay, still looking good. I think there'll have to be a quiz on the math later on. At least I hope not, anyway. And then it looks like we're making a little bit of some color correction in this next part. Let's see what's going on here. Oh, okay. I think this is okay. This is just trying some different experiments. So there's this function or this value in front of the ray color that you can put here. I guess it's, what is that, like the reflectance or something like that. So let's try it with 0.1. I guess the claim on that is that well, if you make it low, I guess it would become real dark. Is that right? Yeah, okay, that's all dark and ominous. I like it. That's good. It's perfect for this project. And then if you make it like high, like 0.8, let's try that. Yeah, okay, I get it there. Let's put it back to 0.5 maybe, just for now. So there's a little bit of discussion about just kind of color space. So it looks like another like little minor. There's like a minor correction in the right color code. Okay, so what have we got going on here? It looks like we have a function called linear to gamma. And just returning the square root, huh? Okay. Okay, so doing that, I have to be a little careful with the type checking on that. And then what is going on here? Okay, it looks like, okay, we have to apply that. Okay. To the pixel colors. And then we're gonna clamp the just those variables now. Okay. Okay, just fixing. Okay, let's make sure that works. Okay, so I had it set at 0.5, which is, I guess, kind of in the middle of this range, and to my eye, it looks pretty close to image 12 there. So, okay, so it looks like section 9. Maybe not a whole lot to that section, other than just a lot, like some very minor code changes throughout, and so I'm not sure whether I have much more to say about that. Just kind of some mathematical discussion. So we're going to start section 10. This is, you should already be scared about section 10. Section 10 is using the word abstraction again, or abstract. And anytime that comes up, you know that bad things are going to happen here. Okay, so one of the things that's happening here is different objects, as noted here, kind of different materials like metal or glass or other things. This is taking us back in the direction of maybe object-oriented programming kinds of things. Like, are we going to have, like, are new materials going to be added to the system later on? Like, how is that going to work? And so what is going on in the project is the introduction of a abstract class. Okay, so there's going to be some kind of material class. Like, huh, okay, that's sort of interesting there. And it looks like there's going to be some method of kind of scattering off of that. As opposed to coding that right away, let's just kind of look forward and see how that's being used. Okay, so there's going to be some abstract class material. It looks like the material is going to be added into hit record. Okay, I guess that makes sense. Okay, so you're gonna have a ray go into a scene. It's gonna hit something. So not only are we gonna have information about like what it hit, sort of maybe the geometry of what got hit, but also the material of what got hit. Okay, so hit record's gonna go there, and then it looks like. Like objects like sphere are going to grow a reference to a material. Okay, so there's going to be some kind of material added on there. And then let's see what else is going on here. Okay, so the scatter thing. The scattering operation looks a little interesting as well. So it looks like there is some kind of bool coming back, and then possibly 2 return values. They're being set kind of at the end. Okay, interesting. Okay, so looks like we have a fair amount of kind of work cut out for us here in terms of how this is going to be used. To start this off, I'm going to create a file, material.rs. Instead of defining a class, this is we're gonna have a trait material that is going to be defined, and then the key feature of this trait is that there's going to be some kind of scatter function being implemented where we have an input ray and some kind of hit record. And then it is returning. Okay, this is the subtle part. These values here, those are basically output value. Okay, those are not input. We'll see that in the code, but what's happening is you're giving this thing like our input ray, an input hit record, and then 2 values are coming back along with a like a bool of some kind. I would say like the bool is more related to this statement if scattered. So we actually don't know if the thing is going to scatter, and if it does, we're going to have some information there. I think the way that I'm going to formulate this is this is going to be an option type of some sort. And I am going to return a tuple that is a color and array. That already looks pretty scary there. Okay, so let's bring in some of the features that we need on this thing. We need to have hit record. We need to have color. We need to have ray. And do we need anything else on that? Let's start with that. Okay, so we're going to start with that as the crate. Again, I'm trying to code this in a more Rust idiomatic way. Okay, so an input ray and a record are going to come in, and then an attenuation and a scattered ray are going to come out. And we don't know if those are going to come out, so I'm going to put that in an option type like that. Let's add this to the project and just make sure that that it actually compiles. So we're going to add that, make sure that Rust is not unhappy with it. Oh, helps if I use the right syntax. Okay, so let's okay, so we're going to return an option of some tuple like that. Okay, so compilation is okay. See how this goes. Next thing we're going to do is we need to introduce the ray. Okay, what is going on here? Okay, this hit record is going to introduce the material. Okay, so we need something in the hit record to have some kind of notion of what actually got hit. Huh, okay. Let's go to hit record for a second here. So there's going to be, we have T, we have P, we have all those features in there. I guess the order doesn't really matter on this, but we are going to introduce a material of some kind. Now, right away, this is okay. So this is getting us back to the earlier problem with the hittable list. Okay, well, let's go back to the hittable list for a second. This is where we had all this stuff with the dine and the box and all this other stuff. Okay, so this material here. This is going to be any material. I mean, it could be metal, it could be glass. We don't know what it's going to be. Because we don't know what it's going to be, that is why I would put dine on here. Dynamic basically means it's dynamically determined. We don't know what it is. Okay, so we're going to have some kind of dynamic material on there. And it may be the kind of thing where like when we create the hit record here, we're going to have some kind of notion of what got hit. Okay, so like what got hit here. And I'm not sure what got hit. Okay, so that is okay. We don't quite know what's gonna go in there yet. I mean, maybe you're thinking like impl material or something like that. Okay, so is it that? There's a secondary question on this. And this is also getting back to the hittable list. Does the hit record own the material or not? Russ is super picky about ownership. It wants every single object to be owned by something. And in this case, I need to think about what is this material that is being put here? Is this some owned value? Does a hit record, is it the owner of that, or is it borrowing the value? What I'm seeing in the C++ code is that he's slapping reference count on it. It's going back to shared pointer here, where it's like, okay, the material is shared by some other thing. I mean, maybe it's being shared by the object that it belongs to, like a sphere or something like that. We could go down that route in Rust if we were to do reference counting. So there is a reference counting type in Rust. I mean, maybe that's the route we could go with that. We haven't done reference counting in this project, but I'm actually not convinced about reference counting. I mean, reference counting is basically about shared ownership, right? It's like, okay, multiple things own the material. So I'm looking at hit record, and it's like, does it make sense for that to have shared ownership of the material? And I'm not sure. I kind of feel like this should probably be a borrow of some kind. Okay, so this is like I should put like ampersand material on there. I mean, here's why. I mean, okay, I'm thinking about the problem. You're shooting the ray in there. It's going to hit some material, or it's going to hit something that is made of some material. The material is owned by the thing that it hit. Like, that's part of the sphere, right? It's like, okay, the you know, or the box or whatever, right? Okay, so it's like owned by the sphere. The hit record doesn't need to take ownership of that. I just need to refer to it, like, you know, indirectly. So I think a borrow is what I want here. It's like I want to have like a borrowed reference to some material. I don't know what kind of material it is, but that's what I'm thinking on this, is that, okay, there's going to be some kind of material that it hits, but I don't own it. And I don't want shared ownership of it either. I just want to have reference to it. Okay, so I'm thinking that is probably what I want. Okay, let's add material in there. Rust is going to be extremely probably unhappy with this. In fact, it's going to probably complain about lifetimes on this thing. It's also going to be complaining about my improper use of import here, or not importing the material name. Okay. Yeah, no, it's complaining about a lot of stuff in here. Not dyne compatible. It's, you know, okay, sized. Yeah, okay, it's really not. It's really not happy here. Okay, let's go back to material first. Okay, first of all, this is missing a self. That is probably why it's complaining about the dyne compatibility thing. It's like the dynamic implies that there's some object, and maybe it's, you know, not happy with that. Okay. The other thing that it's not happy about are lifetimes. So, okay, a lot of things that it's not happy about. Okay, it's missing arguments. Okay, it's missing lifetime specifiers. Okay, let's address the lifetime thing for a second here. The way that I formulated this is that this is essentially a borrow to any material. Okay, and the borrow means I do not own the material. So what Rust is complaining about here is it wants to have some assurance that the material lives at least as long as the hit record does. Like I can't create like a hit record and then have the material like ripped out from underneath it. Otherwise, it would have like a dangling pointer or something like that. That's what it's complaining about. And I'm gonna think to the problem. Okay, that anytime you do lifetimes in Rust, I claim that you need to think about the problem. I'm thinking that in this problem there is some scene that gets set up in advance. Okay, there's some world. You create a bunch of spheres in it. They're made of different materials. That scene is basically frozen. It's like that's like the setup of the problem. This hit record is essentially created in the process of shooting light rays at it, and is a more transient data structure, right? It's like hit record only exists for like a brief period of time. So in my mind, this hit record thing is going to like the material is definitely going to live longer than the hit record is. And so because of that, I think I can get away with putting a lifetime on here. Again, what is going on with the lifetime is I am simply saying that these two things are related to each other, and that the material lives at least as long as the hit record does. Okay, so it looks a little scary, but I kind of have faith in the problem here, that I'm, in this problem, I don't think the material is going to go away. Okay, so I'm gonna introduce lifetime on this. I'm basically going to specify that whatever that material is, it's going to live at least as long as the as long as that is. Okay, so I'm introducing some lifetimes on the hit record here. We're going to see if that makes Rust go quiet about that. Okay, so it's no longer complaining about lifetimes. Now what it's complaining about is that I'm not creating the hit record with a material. Okay, I'm missing a parameter. So let's go deal with that. Okay, so now we have to do the sphere. There's going to be a quiz on this later on. In the sphere, there is going to be a reference to a material. Okay, so there's some material being added to sphere. So let's go to the sphere class here. Okay, sphere object. I think I'm going to take away the name. Forget about the name. Okay, so what we're going to do instead with the sphere is we are going to introduce a maybe I'll leave the lifetime on there. We're going to introduce basically a material at this point. Okay, so this is going to be, material. This, and again, the material we don't know what that's going to be actually. Okay, so this is kind of like that hittable list problem again. Okay, so we're bringing material in here. So this is going to be like dyne material of some kind. Okay, some dynamically determined material. Question is, do I own the material or not? So I have a sphere. It's made of some material. Does the sphere own the material that it's made out of? I think you could probably claim that it does. Okay, this is getting back to understanding the problem. I mean, we could maybe have a debate about this, but I'm going to put this in a box to indicate that the sphere owns the material. Okay, so I'm gonna do that. There was this kind of weird thing that was going on with the hittable list. Let me go back to that hittable list where I had to have a lifetime on this thing. Like when I put when I had the dyne in there. I'm gonna do the same thing here. Again, that's an extremely subtle thing, but what I'm essentially saying is that whatever is inside the material object, which I don't know what it is, has to live at least as long as the sphere does. Okay, so I'm gonna put the material there, and then I'm gonna get rid of the name thing here. And I'm going to say the material, in this case, is it's going to implement material. And it has to have that lifetime. Wow, okay, we're getting into some serious Rust stuff here. The other thing that needs to happen is the material basically needs to go into a box. Okay, so when you create a sphere, I'm going to give you a material is going to come in. I'm going to own it. I'm going to put it in a box and put it in the sphere. One little thing about this box, by the way, there's an alternative thing that I could do here is I could call into. I wanted to show this earlier actually, but what into will do is it will kind of look at what the expected type is, and then it will try to like convert it into that if it can. So I'm gonna try that here. So what I'm doing, doing here again. This is the C++ code over here. This is what I'm doing in Rust. It's a slightly different kind of formulation of it, but what I'm saying is that you're gonna give me some material for the sphere. The sphere is gonna own the sphere. It's gonna own the material. Okay, so it's gonna own what it's made out of. And then the only other change is in this hit record. It looks like when you create the hit record down here. let's go down here, look at the hit record. I need to include the material. And what I'm going to do is I'm going to include a reference to myself. Okay, so the hit record is borrowing the material from the sphere. And I'm going to keep my fingers crossed that all of that works. Okay, so let's build that. Oh, okay, so main is going to be complaining about my functions here. Okay, so let's go back to main for. Oh, actually, we're going to have to implement like a specific thing here too. Okay, so yeah, let's ignore main for a second. Yeah, this isn't even going to work unless I have like a material to work with. Right now, the material is like this totally abstract thing. Some trait material. Okay, so what we've got here is looks like we're introducing a new kind of material in. I guess they're putting it in the material file. Okay, I guess we could do that. It sort of breaks from the trend of putting everything in a separate file, I suppose. Okay, so we're going to have a struct Lambertian, I guess. Oh, it has a private field. Okay, color is already in there. So we've got new, and then what we're going to have to do is implement material for that. So let's put the code in here. So I'm just copying over the C++ code. Okay, now this is where the option thing, okay, so what we're going to return on this is a tuple where we return the attenuation and the scattered ray bang. I'm just bringing in a few pieces of code that we need here. Okay, so I think, do I have color array? Okay. So in the C++ code, I just want to kind of call attention to this. This in the C++ code, this is basically doing a mutation where like we're essentially mutating the arguments and then returning true back as a result to indicate that it's scattered. I'm not doing that here. Okay, so what is happening instead is I'm creating those values. I'm going to return it back as a tuple as an option. Okay, so in some sense the option is representing the bool part of that, and then those are the two return values. I think that's much more idiomatic for Rust. Like mutating things is always kind of weird practice in Rust. It's like I don't really want to do that. Okay, so So we've got that. Now what we need to do, oh, actually, they're making, okay. All right, there's a few more enhancements in the Vec 3 and the material class. Okay, what's going on here? Okay, if scatter direction is near 0, looks like they're just setting it to like some kind of value as a check there. In order to do that, I've got to make that mutable, by the way. Okay, so I change there, and then it looks like I need to go to Vec 3 and add some new helper function in here. I don't know where to put it. Okay, so let's just do like near 0. I'm copying C++ code. Okay. Let's do like const s. I think constant needs to know what type it is in Rust, and then what are we doing? We're returning like okay. I think ABS is actually a method in Rust of Rust float 64. So okay, what is going on? Wow. Okay, there's a lot of code being introduced here. Okay, like a reflection thing going on. Mirrored light reflection. What is going on here? Okay, mirrored light. Oh, okay. Okay, they're actually defining metal here. Okay. Let's see where our compilation stands at the moment. So let attenuation equals. Oh, okay. All right. It's finally complaining about some cloning and copying for the color type. I'm actually surprised they've gotten this far without that. I actually had those defined for Vec 3. I had clone and copy defined on that. Since we're doing more stuff with colors here, I think I'm going to define both of those. Also, just the fact that the original project actually type aliased color to vector to be the same thing. So I'm gonna go ahead. I think we're okay with that. Okay. All right. So it looks like most of the fields. Let's see. Oh, I need to have cell. Okay, losing my mind here on the near zero thing. So we got that. Most of the errors right now in the code are due to the fact that the parameters to the sphere thing are wrong. Basically, I took name away, and then I added a material to that. We could probably just try it right now. I mean, I don't really quite know what is gonna happen here, but mean, what we would need to do when we create a sphere is you would create the sphere, and then there's going to be this this new material thing kind of added in there. And so I could add, I don't know, let's just add something in there and just see what in the world happens. I don't know exactly what is going to happen here, but I don't know, let's just give it different value. Mainly what I'm trying to do is just see if the thing will compile. Expected color. Oh, expects a color instead of a... We'll just make up some random colors. Okay, so this is, again, I'm mainly just trying to figure out if it will like hold together, essentially. Hit record, the trait materials. Okay, got a few little typos. Oh, I need to name the parameter here. Okay, maybe. Okay, that into hack it's hating that. Maybe I need to. Maybe I do need to do a box, like a box new on that. Okay, main. I need color. That. The other thing that's going on in the error messages, it is complaining about the box here. It's okay. So some kind of type issue with that. I think what is going on with that is I need to basically take the material out of the box. This is maybe a little bit cryptic, but I think I probably need a star in there. We'll see if that fixes the problem. Did I not? Oh, triple colon. Okay, that's a dumb arrow. Okay, well, okay, it compiles at this point. Let me just go back to this star thing here. The star basically removes from box, and then the ampersand is like a borrow. So that's a bit of a technicality on that, but it's kind of hidden behind the scenes here. It's like you got to take it out of the box, and then I got to refer to it. So let's do that. It compiles. I have no idea what kind of image this is gonna produce, but let's just see what it does, if anything at all. Okay, so we're a little bit off the book here at the moment. We're off the project, but we've made a lot of code changes, and I'm trying to see whether like the whole code can just fit together in terms of what we did. Okay, so that's okay. That's all right. Is that what we're expecting it to do? Not really sure. So, actually, I'm not even sure whether the like the hittable list is using the scatter thing correctly or not. But at least it seemed to have. At least it holds together. Okay, scanner. Okay, so let's continue on. Okay, so a little bit of a digression there. I just didn't want to get too far through this section 10 with nothing compiling, and then I have to fix like 100 things in the code to get it to compile. So Okay, so we did this one material. Looks like in 10.4 we're introducing yet another material into the mix. We're introducing metal. Also looks like we're introducing a new helper function into Vect3 to do a reflection of some kind. I don't know how you want to, I don't know, I don't know, how do we want to code that? Okay, so we're going to have some function reflect. I'm taking a self and a, well, I don't know what to, well, let's just try this. I'm gonna try it by the book here. Okay. Okay, so we're gonna try that, and then what we're gonna do in material, it looks like we're gonna implement yet another material. Let's go down here. They're putting all these in the same file. Okay, so we're gonna have a struct called metal. I guess it is also going to have a albedo value. Okay, so we're gonna implement material for metal, and that's gonna have that same scatter function in there. Okay, so we're gonna have that, and there's just the difference here is going to be the implementation of the scatter here. Okay, so we're gonna let reflected. So that's metal. Let's see if that compiles. Okay, so that compiles okay, and then it looks like, oh, okay, maybe this is where the material is going to enter the picture. It looks like in the camera we're gonna do something with the scatter here. So where let's see, ray color. So we're gonna do. Okay, we're located here, and we're gonna introduce some new. Oh, okay, this is the mutating of the arguments here. Okay, so it's expecting those to mutate. What I'm gonna do instead is I'm gonna do an if let. Okay, so there's a little pattern match on this thing. So it's like we're basically saying, okay, if the thing's scattered and had that attenuation, then we're gonna do. Okay, we'll return like attenuation. If it's not doing that, it looks like it returns color 0. Okay, let's try that. See if it compiles. Okay, it does not compile. Let's see what we're missing here. Okay, we're missing multiply for color. color here. Okay, interesting. So we're missing a multiplication operation for colors, and I believe that the it's just like an element by element multiply, if I remember right. We can go back and double check with the C++ code in a second. Okay, so let's try putting that on there, and okay, little fiddly detail with the scattered there. Hit record. Okay, once that. Okay, it compiles. It's a little bit of a warning. I'll have to think about what I want to. Well, it is only a warning. I suppose we can just ignore it. It does compile. Let's see let's see what it produces. I just set up those random colors, so I have no idea what this is going to produce as output, but we'll see what happens here. Okay, very wow, very festive, very holiday looking there. Okay, why don't we do what they do in the book? What they have here is they're going to make a scene that has metal spheres. So they're going to make some materials and then add them to the world. And then okay, let's try to do that. Okay, so we're gonna make the world here. Let's. We have two materials that are at our disposal. We have the Lambertian and metal here. Okay, so let's do that. So yeah, the setup on this is always fun. So I'm missing a comma. Okay, so we've got the metal there, and then what we're gonna do is add some spheres to the world. Let's we'll just start fresh with that. Okay, so we're gonna do world add sphere new 0.3 new. One thing about that's really subtle about this is that operation that is making the sphere is taking ownership of the material. It turns out that the ground in this case would actually not be usable again. So if you wanted to reuse the material in something else, you'd have to maybe clone it or some other thing. .0, 0.1. I'm just looking at it to make sure that it's not filled with syntax errors or anything like that. I don't know. Let's go for it and just see what happens. Metal new. Oh, did I not give a maybe? Yeah, maybe. Okay, maybe I didn't implement metal here. Okay. No, I did not. Okay, I need to give it a. Okay, we're gonna keep our fingers crossed if we can get something that looks like that. Wow. Okay. Awesome. Okay, so we've got that. What is coming up? A fuzzy reflection. Okay, so one little. Okay, let's do one little extra thing here, and okay, so they're introducing fuzz to the metal here. Okay. What is fuzz? I guess okay. That's a double there. Okay, here's something that's kind of, this is going to be a little bit questionable on my part. They're doing a little bit of a, like an initialization of the fuzz in there, kind of making sure that it's less than 1. So I could just embed like an if statement in here. And then do that. Pretty sure that will work. It might look a little crazy to do that, but I can do that. And let's see. Okay, so then they're doing. Let's see. What are they changing here? Okay, so they do the reflected thing, and then it looks like they just mutated, I guess. Okay, so we're gonna do reflected equals unit vector. Is unit vector? I'm just trying to say, did I make that a method? So many pieces of code on this thing. Unit vector. Okay, so that's a method. Okay, so they're adding that in, and then there's like a little bit of a check to do like a Boolean thing here. Okay, so this is sort of interesting. So if that's greater than 0, then we're going to return the thing. Otherwise, we're going to return none. Okay, interesting. I might need dot import. I'm going to have to fix that dot product thing. The fact that I did not put that on the vec3 class is kind of annoying. Maybe I'll get around to that at some point. Okay, so we're adding in the fuzz, and then it looks like in the main. And now we need to introduce some fuzz to the metal here. Okay, so we're gonna put like 0.3 and 1.0. Metal with fuzziness. Okay. Okay, let's see whether this compiles and runs or not. Oh, just a little type error. And another little type error. Rust is really, really picky about the numeric types being correct on things. Okay, it's looking kind of fuzzy there. Okay, I'm going to take another quick break and pause the recording. So we'll start again in a second. Okay, we're going to resume. Before we resume, I just wanted to make one comment about a piece of code that we had earlier. And it was the fact that I used lifetimes on the hit record. When programming Rust, it can be really easy to have like a fear of lifetimes where it's like, oh God, I'm gonna have all sorts of borrow checker problems. In this case, I didn't really have problems with it because I sort of understood the problem. I understood that materials are gonna be owned by the hittable object, and the fact that I'm borrowing it here is not really gonna present a problem to Rust. And in fact, it did not. Like when I was coding all that, I didn't really run into a whole lot of borrow checker problems. So one thing to maybe think about when you're doing borrows in Rust is just, does it make sense to borrow in the context of the problem that you're solving? And if it does, you're probably going to be okay. You may find that the code just works. There's still a lot of details with ownership and other things that you need to think about, but that's just one thing to keep in mind. What is coming up is we're going to add yet another material into the mix. So there's kind of the addition of glass into the mix. So I'm going to code that up. Probably not going to talk about it too much because we've actually done all of the hard work in terms of getting this thing to just kind of fit together. Okay, so I'm gonna kind of code this in pieces. I give a lot of code fragments. I'm just gonna kind of work through this. So we're gonna add some stuff to vector 3 to do essentially a refraction. So I'm gonna add that. Paper has all of the math of this, which at this point I don't even want to think about. I'm going to assume that it's correct. Oh, I think there's, I'm trying to remember how to do a comparison in Rust. It might be like, I think there's like a compare. We'll find out about that. Okay. Okay, this is a little bit of a nightmare here. So we're doing length squared, and then we're taking the absolute value of that. I'm gonna put some parentheses around all this, just so I can keep straight in my mind what we're doing, and then we're taking the square root of that. Negating that. could probably write that a lot better, but the fact that it's a method in Rust makes it a little bit hard to kind of, it sort of reads a little bit, getting a little bit backwards than what I'm used to on that. Okay, so let's do that. Let's see if that compiles. I'm not exactly sure about this minimum calculation there. Okay, so let's bring that in. What else are we? The trait, or I mean, let's see. Is that might need F? It might be fmin. Could also just be a method on floats too. That occurs to me as well. Okay, yeah, min. Okay, so that at least compiles. Let me take out the comparison thing. Okay, so we got the reflection. Now it looks like we're introducing a new material. Make sure I'm spelling it correctly. New method. Then we're going to have to implement the material trait for that. We'll just copy it from somewhere else and then adapt it. Okay, so we got like a little ternary operator here in C++. You have to have the extra semicolon on the end because I'm assigning to a variable here. Okay, so there's that. So it looks like what we're going to do is change one of the materials to a dielectric. Let's try that. Okay, let's see if let's see if it builds and whether we can do anything here. Dielectric new. Okay, well, it builds okay. Let's see what happens. The drama of watching it run while it's doing its thing here. Okay, that's looking good. Let's continue on here. Got a little bit of math about reflections. Okay, it looks like some enhancements to the scatter function in here. So let's just kind of work on that. What's the unit direction? This is bringing back flashbacks to doing trig identities in like trigonometry class. Okay, here's kind of an interesting thing. Okay, so it's like this here, you've got like this direction that's being created, and then I'm setting it based on two different things here. I think Rust. Okay, this is gonna look a little crazy, but let's see what happens here. The reason that looks a little crazy is like I basically I just said let direction, and then I never gave it any kind of value. And then on top of that, what I'm doing is I'm like now mutating it. It doesn't even have like a mute on it. And it's like, is that even going to compile? Let's see what happens. Let's see, refresh. Oh, I need, okay, just have the variable name wrong here. Okay, so that actually compiled and ran. I mean, this is maybe a little bit of a subtle comment on Rust, but it is kind of smart enough to figure out what's going on. I mean, if you say let direction, you're sort of establishing that as a variable, but Rust will figure out what its type is based on how it's used. And not only that, it doesn't have to be mutable in this case, because it's basically smart enough to know that it only got assigned once in the different branches of that if statement. So it's kind of, I don't know, think of direction as like a placeholder at this point in time, and then it gets set to some value, and it's like, yeah, okay, cool, okay. So, all right, so we're working through here. It looks like it works the same, and he talks about no change in the scene, but then there's like a slight change in main. Okay, with a slightly different refraction there. Okay, so let's go to main and do what is written there. See what happens. Hopefully we'll see this like little air bubble in there. So or like a little thing on the edge there. Yeah, okay, that's looking good. And let's see. There's little extra little hack kind of added onto this. Let's do this. Okay, what is he doing here? Okay, they're introducing a new method on material on the dielectric. Okay, looks like there's a new method, reflectance. What is that? That doesn't even look like a method. That just looks like a function of some kind, some static function. Again, having to be careful with the 1.0 on that. Okay, that's kind of a strange way to compute that. Oh, power. I wonder what that. I can't remember what the power operation is in Rust, so I don't know whether I don't know if that's going to compile or not. But let's see what happens here. Now, power F. Well, actually, let's see if there's a power with an integer on it. No. Okay. Oh, I didn't save that. Okay. Nah, okay, it's power F here. Okay, so power, and then let's well, that actually is a method because it is using the refraction index. Okay. I need probably a random number thing in here. Let's see if that works. Okay, I'm going to run it again to make sure the image isn't all messed up. Okay, that's still looking okay, I guess. At least close enough to my eye, anyway. Let's see, we've got this, okay, we're gonna model a hollow glass sphere. Okay, this looks like a change to the main program. So what we got left, material left is gonna be 1.5, and then we're gonna have material, what is it, bubble? Okay. Doing here, I guess we're adding a new sphere into the mix with a very slightly less radius. And run that. Okay. Feels like we're finally making like some progress here on the project, getting to something interesting. So okay, that's looking pretty good. So got glass working. Section 12 is going to do some stuff with the camera. I'm gonna just give you a little advance warning on this. This section is involves like a tremendous amount of very detailed mathematical calculations that we need to kind of figure out, and it's almost all related to the camera. Okay, so I'm gonna work through this. Well, I mean, I guess we're gonna grind through this for better or for worse. So let's just get going on it. So it's going to be a lot of just introducing new variables into the mix, and then initializing those variables, and then there's also a lot of room for making lots of typos, like mathematical typos and other things. So this is going to be a lot of fun here. Okay. Okay, so they're setting up a default field of view of 90. And then there's a whole bunch of stuff in the initialize down here. Focal length. I think that there's a method on Rust floats to do radian conversion. Might be 2 radians. We'll check that out in a second. I know that tangent is a method. Okay, we're going to change the viewport height. I'm going to comment out some lines that were there before, just in case I mess it up. Okay, so here we're introducing like an adjustable field of view. Okay, he introduces like there's like a whole nother scene introduced here. I'm not gonna do that. I'm gonna just try to run it and see if I can get it to compile and do something. Okay. Okay, so that gives us that, and then I'm gonna make like just a change to the field of view and see what happens here. What is a vertical field of view? I think if we narrow it in, like if I said like 45 or something like that, it might zoom in on the image. So let's just try that. Like narrowing the camera. Okay, that did what I expected. It kind of zoomed in on the image there. Okay, so that's field of view calculation. The next step of this is just positioning the camera so that you can look in different directions. Okay, so this looks pretty kind of hairy over here on the left, but this is just more details with the camera struct. So let's go ahead and just grind through it here. So it's going to introduce more public variables. Look from 3. Look at 3. Be up. Back 3. Okay, so I'm going to have that. It looks like it's going to introduce a few more private variables. Ooh, good. One letter variable names. Gotta love that. Okay, so 3 vectors there. Some of these values have default values, so let me set those up. Set that. I also have to do the U and the V and the W. Okay. Those are going to get set later on, but they have to have some kind of default value set here. I'm kind of wondering whether this is the time to talk about default values. Maybe it is. Okay, this is actually getting a little bit annoying, having to initialize the private variables like that. So let me talk about that for a second. If you have a structure that has like a whole bunch of variables like that, one thing that you might be able to do is basically put like a derived default on it. Okay, so I'm gonna say derived default on there. And then what you can do with that is down here when you're initializing the public variables. Okay, so we're gonna initialize sort of like public stuff, public variables. I can come in here at the end of this and essentially just tell Rust. The syntax is a little weird, but what I will do is something like this. I would just say, why don't you just do default like that? And then it will take care of all the private variables for me. Okay, let me comment that out for a second. Okay, so just go back here. Okay, so there's a trait or something you can derive on your structure to essentially do that. So what I've done is I put the default on there. Now that will work, but I may need to define that for some of my other data structures. Like I'm using vec and point, like vec3 and point and stuff like that in here. In order for that to work, I basically need to derive it for those as well. So it's kind of like clone in the same sense. So I need to come up here and basically say I want to derive default on there. Let's see if that. Yeah, okay, so that seemed to work okay. That basically just saves me the headache of having to do all this like private variable initialization. I'm running it just to make sure that I get the same image as before, because that would be really unfortunate if I didn't. So let me start with that. Okay, so we're back in business here. So that's a useful trick. Kind of know about. You can derive default values for arguments, and so now what I'm only doing is I'm just focused on the public, like the public attributes in my camera class. Okay, so I'm gonna do that. Now it looks like we've got. Well, okay, we got a whole bunch of stuff going on in the initialization of this. So it looks like the center is going to be the look from value. The focal length is going to be look from minus look at length. Viewport width. Okay, now we're okay, so this looks a little bit hairy to me, but okay, so this is going to be looks like self look from minus self look at, and then we're going to turn that into a unit vector. And then self.u is going to be, oh, I don't know whether we've implemented cross product yet, but it's going to be the v up, self.w. Vector. V is going to be the cross product of W and U. Okay. Let's start with that. Let me let's continue with the changes here. And then we're going to have to implement cross product. I know we have not implemented that yet. So let's continue on with the changes here. Let's see, this viewport width is that okay? So this is going to be. Viewport V is going to be viewport height. Minus self V. And then we're making a change to the upper thing here. So this is going to be self less center. Minus focal length, no, okay. I'm definitely glad this is not a trigonometry class. Having to explain everything that is going on here. Okay, so making those changes. Okay, we definitely need the cross product. So let's go to Vec3 and implement the cross product. Unlike what I did with the dot down here, I am going to implement cross as part of the maybe the Vec3 struct, if you will. I might fix dot product while I'm at it, but let's do the cross. I actually knew that I was going to need to do this, so I'm going to pull up the code for the cross product here. just to make sure that I'm implementing that correctly. Okay, so this is, it's going to be u dot y times v dot z minus u dot z times v dot y. I don't know why he did this like screwy, like array in the C++ code. Let's see, minus u dot x times v dot z. So that looks like the cross product. Let's just make sure that I got that right. Okay, so that's y and z, and then z and y, and then z and x and z, and then x and y, and then y and x. Okay, so we're gonna do that. I'm gonna move dot up here too, just because I was sort of annoyed with the way that was working in the earlier code. Okay, so I'm gonna make a code change to move the dot product up there too. This is probably gonna break the whole universe of code that I had before. So let me go through and like, okay, so everywhere that I had the dot is now gonna be like vec3 dot. Did I not use it in there? Okay, so let's do that. Maybe in the material, was there some dot stuff? Okay, so that's going to be vec3 dot. I'm probably missing that in a few other spots. Okay, so like I might even be missing it in the vec3 thing somewhere too. Yeah, vec3 dot. Okay, let's just see if we're holding it together here. Can call numeric type. Random range. Oh, let's take the vec3 off the front of it there. Self.u. Sphere. Yeah, some of the fearless refactoring on Rust here. Okay, so let's just kind of fix that. Oh, okay. Maybe I need I need vec3 up here too. And inhittable. Okay, naturally and. Okay, we got that piece back together here. Let's continue on. So let's see, do they make the... Okay, so they're going to keep we're going to keep the thing that we had before with the bubble, but it looks like they're introducing some different, just a different scene here. So let's go back here and set that up. This is the part of the project where I always get really scared, because you've just made like a tremendous number of changes to things, and then it's either gonna just, it will either work, or it's gonna just produce this like massive like mathematical error, and then I'm gonna have to pause the recording and spend like an hour figuring out what sign I screwed up in the mathematical calculation or something like that. Okay, let's see what happens here. Let's just be optimistic and assume that it's going to work here. Could not compile. Let's see. Do I have a? No. Okay. Let's actually use the proper Rust syntax here. That would be good. I'm going to keep my fingers crossed that this works. Otherwise, I'm going to be hating life in a second. Oh, okay, awesome. Okay, do that. And then let's do the other thing that they changed down here. What did they change the field of view to 20? Let's run that. Definitely taking a little bit longer time to do that. Okay, that's looking good. Oh, okay. Final feature. Wow, making progress here. Defocus Blur. What is this? Okay, a lot of mathematical calculations and okay, looks like we're gonna have yet another feature of the Vec3. Okay, let's go. Let's soldier on here. Okay, so we're gonna have a what is this? Random unit disk. Turning to Vec3. Gonna go into a loop. That looks like a hack if I ever saw one there. Okay, Pete. Let's see, we're introducing some more stuff onto the camera. Wow, okay. Okay, so we're getting like a few more public variables showing up. A few more private variables. Let's see. The default thing should take care of that. Looks like we're making a few more changes to our initialization here. Okay, so one of the things that's going away, it looks like, is the focal length. Okay, so that's going away. And then the viewport height is incorporating the focus distance. So that's going there. this thing now incorporates the focus distance. Was that an attribute? Oh, that was okay, that's okay, that's now an attribute. Okay, so this is going to be like the focus distance here. And then we have like a few more things, like a few additional things. Okay, defocus radius equals focus distance times we're going to convert that to radians. Take the tangent of it. I'm just concerned about the order of like the order of operations on here. The tangent. So then we're doing that. Let's see what's going on here. We're doing like a little slight change on this. Okay, so we need another function here. Okay, defocus the disk sample. I'm trying to remember what is a function on Vec3 and what is not. Let's see. Oh, this is interesting. Now all of a sudden he's like doing like indexing in there, and I gotta do that. Okay, I guess the moment of truth as to whether this is going to compile. Let's see what's going on here. Yeah, okay, I got a bug somewhere. Multiply. What are we missing here? Self.v times defocus radius. Oh, okay. That's probably because the multiply is put on the other side. Let's see. Where is that? Oh, 9. Yeah, let's just enjoy like commutivity here. Let's put it on the other side. Now, okay, we're compiling, we're running. We're gonna see what we get here. Keep the fingers crossed. Hope that it works. Otherwise, we're going to be in debugging hell with the math. Oh, okay, we're in. Okay, good. Okay, making progress. Where next? We're in the final render here. Okay, so let's okay. This is gonna be a new main or some new main function here. Let me call this old main, and we're gonna make a new one. Main. Okay, looks like we're at the end of the line here. Okay, so hittable list new, and let's just kind of, I don't know. Okay, let's see what we got here. Look, okay, so we're gonna basically make a bunch of random spheres, I think. Okay, like a gigantic sphere, radius 1,000 there. Okay, that's kind of interesting. Looks like we're gonna do a big nested loop here. Okay, we're gonna randomly choose something. Let's bring in that. Well, let's see what is going on here. Center. Okay, that looks like a point that is being created here. Okay, so we're gonna do A as F60 floor plus. So making a random center. Okay, I think I've got that coded right. Okay, so let's see. Center minus 0.4, 0.20. If it's greater than 0.9. We're gonna make a like a material. I actually don't know what it is yet. And we're gonna basically pick out a material. Oh, did we make like a color? Yeah, okay. Looks like there's like a random color thing here. I might have to code that up. Okay, random range for the color here. Let's see, 0.5 to 1.0. A little bit of fuzz. Okay, this is going to be glass. So let's see, sphere material. Let's see, we're going to add this to the world at this point. Okay, so we're going to add a sphere. We have the center point, 0.2, and the sphere material. Okay, so we got that, and then it looks like we've got a few more things going on down here. Let's see, material 1. By typing this in, I'm adding to the suspense of the whole affair here. You know, like is this code gonna work, and is it not gonna work? Okay, let's see, where are we going here? This sphere is at negative 4.0, 1.0, 0.0. Just making sure, okay, putting them in the right place. 0, 0, material, okay, material 2. And then let's see, we have material 3. Say 0.7, 0.6, 0.5, and then there's no fuzz factor on it, so let's do that. This is going to be at 4.0, 1.0, 0, 0, material 3. And then we've got to set up the camera here. I don't need to type all that in. Let's just kind of copy that. Okay, so we're going to create the camera. We're going to do a whole bunch of setup on it. We probably, okay, these some of these need to be kind of fixed a little bit. Again, just Russ being picky about numeric types. That's a vector, okay. Actually, it probably would have worked with a point, because vectors and points are aliased to each other. Okay, so we have that. The only thing that occurs to me that I did not implement is this random thing for colors. That was a consequence of me keeping colors and vectors separately. So I'm gonna copy that code over from color or from vector here. I might have to reconsider my design on the keeping colors, like vectors and colors, separate. So maybe that was not the best choice, but I'm not going to worry about it right now. Okay, let's go back to main and just take a look at it. Okay, let's just build it and see what happens. It's probably going to be some errors in here. Okay, just got to pass a borrow to the render there. Maybe missing a few. Expected lamp sphere material. Okay. Oh, okay. Yeah, okay. That's a little annoying. Because the types are not the same. I can't really do this thing that I was doing here. So what I'm gonna do is I'm not happy about this, but I'm just gonna basically make the sphere material its own thing, and I'm gonna move the world add inside. Actually, it kind of occurs to me that maybe the C++ code did the same thing. Maybe they were onto something there. Okay. I got like an extra line in there somewhere. Okay, let's try that. Random 64. Oh, the fuzz. Random range. I need to import that. The suspense is building like probably a lot here. Okay, let's bring in that. Let's see, random. What did I call that? Util. Random F64 array. Using create util. Did I not save it? Let's see. Oh, that's in color. Okay. No. Okay, I gotta pull that into color. Oh, okay, compiled. The moment of truth. Is this thing gonna run? And how long is it gonna run? Let's see how slow it is. Oh, good God, 600. No. Let's change the image size. Let's scale it down a little bit. I don't want to wait for like for forever on that. Let's see. The original image width was like 400 or something like that. Okay, so let's scale it down to that. Okay, let's try this. It's still not super fast. Let's try running it in release mode. We haven't done anything with release mode. Release mode would probably be faster. So okay, let's going through the code. Got a minute to sort of see if this thing is gonna work or not. I guess while it's working on it, we're kind of at the end. I mean, we're either gonna get this final scene or it's gonna be like a disaster, and I'm gonna have to pause recording and go debugging or something like that. But we're kind of at the end of the project here. There's some other projects you can look at. In terms of just the Rust coding on this thing, maybe some of the highlights of this project, I would say, a lot of the code has been straightforward. Maybe, I don't know, like defining data structures and traits and things like that has been pretty straightforward. I would say that by far the trickiest part of this project has definitely been in like the implementation of that hittable list with the lifetimes and things like that. That was actually quite subtle what was happening with that. Also the like the hit record and thing where we got into lifetimes with materials and things like that. That there's a lot of subtlety kind of wrapped up in that. And that might require sort of further study. While this thing is running, by the way, I'm just going to kind of look at it and just kind of eyeball it to make sure I didn't make any typos. Maybe I'm doing a little bit of premature debugging here, but I'm just gonna kind of look at it while it kind of cranks through that and make sure that we look okay. Yeah, okay, that looks okay. It'd be a shame if I had like a massive mathematical error in this, and then material one. It's the tension building up as it runs here. 0.6, 7.6.5, V1 1.0. 16.9. Yeah, okay. Looks like what was specified there. It's definitely not fast, that's for sure, but it's churning away. The tension building as it enters its final like 25 seconds here. The moment of truth. Awesome. That's it. Ray tracing in one weekend in Rust. Now I'm going to pause the recording. I hope you enjoyed this. It was a lot of fun. I'm going to pause the recording for a second because I need to go somewhere, actually. But when I come back, I actually want to do a little postscript where I compare this code to the C++ code. So the original C++ code I have, and what I would like to do is put Rust in like a little performance battle. Like how fast, I didn't really spend any effort optimizing this. I want to see like how fast is the Rust code compared to the C++ code. So the recording's gonna pause for a second, but I'm gonna talk about that next. Okay, I'm back for a little postscript. Since we reached the end, one question that you might wonder is just how does this Rust code compare to the C++ code? So Rust is often pitched as replacement for C++. It's supposed to be fast like C++ and so forth. In implementing the project, I have very much had a focus on what I would call code clarity over performance. So in a lot of the code that I've written, it basically looks the same as the C++. And I've been really trying to avoid putting a lot of really like fiddly details on it. You don't see me calling clone a lot. I'm not using like ampersands a lot. It's not littered with like really kind of weird stuff. So I've been trying to code it in a very clean way. I have not been focused on performance at all. Like that has not been a goal. But but it might be. You might wonder like, how does this thing to compare? So what I thought I would do at the end here is I thought I would just kind of dial down the workload a little bit. So I'm going to make it run a little bit faster. And maybe one of the things that we would want to do is try to put it in like kind of like a head-to-head battle with maybe like the C++ code, which I have, and I'll show you in a second. So I've built this in release mode, and what I'm gonna do is just do a time. I'm gonna run it with the Unix time command, and then just run it into ImageCAD. See what happens. Okay, so this is the Rust code. It should run a little bit faster than before because I dialed down the number of samples. Samples per pixel was like 500 before or something like that. So hopefully this won't take too long. It doesn't quite have the drama as before if it runs faster. This really gives you appreciation for the real-time ray tracing on graphics cards and things like that for what must be going on there, given how long this takes. The ImageCAD. Okay, so that took, this is only going to be like a rough ballpark. I'm writing it down. Like, what was it, 59.6 seconds? About a minute to do that. Okay, so I have the C++ code on my machine. I have to go up to a different directory for that, but let's go into the C++ code. This is essentially the code that was from the book. Okay, so it's the same code from the book. I have not changed it. Well, I've changed it to just have the same parameters as before. So an image width of 400, samples per pixel 100, 20. Yeah, I'm pretty sure it's this. Everything is the same about that. What I'm going to do with this is run it through Clang with a little bit of optimization. That may not be the most optimal setting, but we'll find out. Okay, so let's just kind of run it through the Clang compiler and turn it into a program, and I'm going to do exactly the same thing actually. So what I'm going to do is time the ray trace program piped through ImageCAD, and we're just gonna we're gonna see what happens with this. Okay, so this is. Keep in mind, this is not a scientific study by any means, but it's just kind of take what I got at the end of the project, compile it, compare it to the C++ code from the book. This is the author's C++ code. I haven't touched it in any way, and we'll just see how it turns out. So a lot of factors that could probably affect the performance here. The fact that random numbers are being used all over the place, and I didn't make any attempt at seeding Rust and C++ in the same way. So, there's going to be some variation there, but I'm hoping it will all kind of just wash out the average, basically. So, just see how long this takes. To my eye, it looks about the same, but we'll see here in a second. 65 seconds. Wow. Okay, so my, yeah, 65.74 seconds. So it's a rough ballpark. I have Rust sort of beating the C++ by about 6 seconds. It's not bad considering I didn't make any effort at optimizing it. Okay, so anyway, that's the end of the ray tracing. We could, you know, that's probably a discussion for a different time why Rust is faster. But that's the end of the ray trace project. I hope you enjoyed this. If you want to take a Rust class with me, go to my website. I'm teaching a few. So okay, thanks for watching.